Hi GOH, this is Unit 3, Lesson 6, and today we're going to talk about the properties of parallel lines. So I think you'll find this a little bit easier than the proofs that we've been doing. We talked about parallel lines a little bit when we were talking about rigid motions in Unit 2, and we're just going to start off by reviewing some terminology that you should know. So in exercise 1, lines M and N are parallel to each other. The symbol that I use for parallel are these two straight up and down parallel lines, and they're cut by transversal R. So when you have two parallel lines cut by a transversal, there are actually 8 angles that are formed. So we're first going to talk about corresponding angles. The corresponding angles are the angles that correspond or sort of match up to each other. So if you look at, and I'll color code these, if you look at angle 1 and angle 6, those are corresponding angles and they are congruent to each other. They're both in the same spot, they're both above the parallel line, they're both to the left of the transversal. And then we have angle 3 and angle 5. Those are also corresponding angles, and those are equal to each other. They correspond, they match up. They're both below the parallel line and to the left of the transversal. And then we have angle 7 and angle 2. Those are corresponding angles. They're both above the parallel line, but they're to the right of the transversal, so they correspond to each other. They match up. And then the last two that I have, just looking for a light color here, 8 and 4 are corresponding angles. Those are also congruent to each other. Okay, they're in the same spot. They're below the parallel line and to the right of the transversal. Another thing that you talked about in middle school probably was alternate interior angles. So my interior angles are the angles that are between the parallel lines, okay, and they're on opposite sides of the transversal. So alternate interior angles. So I'm actually going to erase these that I have highlighted. So my alternate interior angles, 2 and 5 are alternate interior angles. They're interior because they're between the parallel lines, and they're alternate because they're on opposite sides of that transversal. Alternate interior angles are also congruent to each other. And then I have one more pair of alternate interior angles, and that's angle 1 and angle 8. Those are also congruent to each other. Okay, so what's true about corresponding angles? They are all congruent to each other. And what's true about alternate interior angles? They are also congruent to each other. All right, so let's look at a problem. In exercise 2, R is parallel to S. Explain why angle 1 equals 47 degrees. Once you know there's 8 angles that are formed, and once I give you one of the angles, you actually know all of the angles. Let me call this angle 2 right there. Okay? Angle 2 is congruent to the 133 because they are corresponding angles. They're in the same spot. I'll highlight them for you so you can see it. So angle 2 and this 133 are corresponding angles. All right? And then 1 and 2 form a linear pair. They have to be equal to 180. So I'm just going to do 180 minus 133 is 47. So that's what angle 1 is. All right, so basically angle 2 is 133 because these guys are congruent, and then these form a linear pair, so that's 47. Once you know one angle, you actually know the rest of them. Like this would be 47 because they're vertical angles. This would be 133 because those are vertical angles. This would be 133 because they're vertical angles. But you can see that these are also alternate interior angles, the ones that I just circled. This would be 47 because it's alternate interior angle, or it's a linear pair with the 133 right next to it. And this is 47 because it is a vertical angle. All right, multiple choice. So this one gets a little bit more confusing because I actually have 2 transversals forming this triangle in the middle. So EF is parallel to DC, angle ABC, so just follow the order of the letters there, ABC, so this angle right here that I am tracing with my pen is 112, and angle EAD, which is up here, is 24. Which of the following represents a measure of angle DAB, which is right there? 2 different ways that you can do this. This one right here is 68 degrees. See how these form a linear pair? All right, these two angles form a line, so they're a linear pair. That makes this 68 because these are, let me highlight them, these are alternate interior angles, so those are congruent to each other. There's also a relationship, which we didn't talk about yet, between these two angles. We call them same side interior angles. And same side interior angles are supplementary. They equal 180. They're interior angles, they're between the parallel lines, and they're same side interior. And then basically, let me highlight these guys, maybe in a pink, although I might have to erase this first. So if I highlight these guys all in pink, these three together also form a line. Look at this line right here. So together they form a line. They have to equal 180. So let's add the two angles that I know, the 24 and the 68, and that equals 92. And then I'm just going to subtract from 180. And that gives me 88. So this angle right here in the middle is 88 degrees. Okay? There are other ways that you could have done it as well. All right, so two major parallel line properties will be used extensively and proved, both in this unit and in follow-up units. The remainder of this lesson, we will use properties to prove some very important results. So what I want to do in exercise 4, I know lines M and N are parallel, and they have that transversal R. Angles are numbered as shown. They want me to prove that angle 1 and angle 2 are supplementary. So that's going to start off by being my given, step 1. Now supplementary means that they equal 180. So that's my given. All right, so 1 and 3 are supplementary. Now these are what, remember I called on the other page, these are same side interior angles. So yes, they are supplementary. I'm sorry, that's what I want to prove. I take that totally back. All right, let's erase this. The only thing I know, I got confused for a second, that's what I'm trying to prove, so I don't know that. I know that M and N are parallel, so M is parallel to N, given. If M is parallel to N, then angle 1 is congruent to angle 2. Look at angle 1 and look at angle 2. Those are alternate interior angles, and alternate interior angles are congruent to each other. All right, so alternate interior angles congruent. I also know, looking at the picture, that angle 2 plus angle 3 equals 180. Now, how do I know that? Because they are a linear pair. Angles that form a line equal 180. Okay, so angle 2 and angle 3 equal 180. Well, if angle 1 is congruent to angle 2 and angle 2 and angle 3 equal 180, I can take this angle 1, since it's equal to angle 2, I'm going to substitute it in for angle 2 right there. So instead of saying angle 2 plus angle 3 equals 180, I'm going to say angle 1 plus angle 3 equals 180. And that's called substitution. Equals can be substituted in for equals. And what I ultimately wanted to prove is that angle 1 and angle 3 are supplementary. Well, if they equal 180, they are supplementary. So angle 1 and angle 3 are supplementary. And that's basically just the definition of supplementary angles. Two angles that equal 180 degrees are supplementary. So definition of supplementary. That wasn't too bad. All right. And one of the most well-known properties of triangles, regardless of their size, the measure of their three angles will always equal to 180. So that's something that you probably already knew before. The three angles of a triangle will always equal 180. The next exercise that we're going to do is actually going to prove that. So this is something that you previously knew before, but have never proven, and now we're going to prove it. So in exercise 5, triangle ABC has been drawn. Side BC has been extended, so I just took BC and I extended that side to D. Point E has been located such that it's an auxiliary segment. So an auxiliary segment is this dotted line right here. It's a line that's added to a problem to help us prove something. And it was specifically drawn so that CE is parallel to AB. So the AB and CB right here are actually parallel. So that's my symbol for parallel that I just added in there. What does allow us to draw segment CE such that it's parallel to AB? Well, we learned back in Unit 1 that if I have a line and a point, there's only one line that I can draw that will be parallel, that will go through that point and be parallel to the other line. So through any point not on a line, one line may be drawn through the point parallel to the original. So through any point not on a line, one line may be drawn through the point parallel to the original line. So that's what allows me to draw that auxiliary line and also stipulate that it is parallel. Now that I know that AB is parallel to CE, what angle must be equal to measure of angle 1? All right, so let's look at angle 1. Here's angle 1. You can extend these parallel lines if you wanted to. You certainly don't need to, but if I extend these lines and extend this transversal and sort of turn my paper a little bit, angle 1 and angle 4 will actually be my alternate interior angles. So angle 1 is congruent to angle 4. They are alternate interior angles. Okay? Given that AB is parallel to CD, what angle must be equal to the measure of angle 2? Again, angle 2 and angle 5, if you turn your paper, you can see that those are corresponding angles. They're in the same spot. They're both below the parallel line. They're both to the right of that transversal BD. So angle 2 is congruent to angle 5, and those are corresponding angles. So now why can we conclude that angle 1 plus angle 2 plus angle 3 equals 180? Well, look at angle 3, 4, and 5, and I am going to circle them in red. Angle 3, angle 4, and angle 5 all form this line. So angle 3 plus angle 4, and my pen's not writing, there we go, plus angle 4 plus angle 5 equal 180. Why? They form a line. Okay, well that's nice, but they wanted me to prove angle 1 plus angle 2 plus angle 3 equals 180. Well, I know I'm going to substitute angle 1 for angle 4. Okay, so in place of this angle 4 here, I'm going to substitute angle 1. I'm going to substitute angle 2 for angle 5. Again, because I know that angle 2 is equal to angle 5, so I'm going to substitute angle 2 for angle 5. So this angle 5, I'm going to substitute that with angle 2. Whoops. All right, so I'm just substituting. And angle 3 is perfect the way it is. So I have angle 3 plus angle 1 plus angle 2 equals 180. All right, if you want, I can highlight those substitutions. So I just substituted angle 2 for angle 5, and I substituted angle 1 for angle 4. The reason is because angle 1 and 4 were congruent, and also angle 2 and angle 5 were congruent. All right, so I just did a little substitution there. And that's it. So we're going to work with that tomorrow.